We all know how to find the derivative of a function. But what is the function whose derivative is known? The process by which we can calculate original function whose derivative is known, that is called integration. If the derivative of a function is given, then the function itself is called integral. It is also called antiderivative. So we can say that finding an integral is reverse of finding a derivative. In this video, we will learn how to calculate integral. The symbol for integral is a stylish long S. After this symbol, we write the function. Function is also called integrand. Okay, and then after that we write dx. Dx tells you which variable to integrate. So that's why you will see dx with a function in terms of x. If we see dy, that function is in terms of y. If we see dt, that function is in terms of t. So for example, how to calculate the integral of x dx. Here x is the integrand whose integral we want to calculate. So what is the rule of integration here? We apply power rule that says that if we want to calculate the integral of x raised to n dx, it will be x raised to n plus 1 upon n plus 1 plus c. So in this example of integral of x dx, it will be x raised to 1 plus 1, because power of x is 1 here, so it will be 1 plus 1 plus c. So it will be x raised to 2 upon 2 plus c. But what is the c here? Why c? C is the constant of integration. Take an example. There can be many functions whose derivative is 2x. For example, derivative of x square is 2x. Derivative of x square plus 4 is 2x. Derivative of x square minus 100 is 2x. So let's recall the rule of derivative first. Derivative of x raised to n is n into x raised to n minus 1 into 1. 1 is the derivative of x. So it will be n x raised to n minus 1. So in this example, if we take x raised to 2, it will be 2x raised to 2 minus 1 into 1. So it will be 2x. If we calculate the derivative of x square plus 4, it will be 2x, which is the derivative of x square, plus 0. We know 4 is the constant here. Derivative of a constant is always 0. So similarly, derivative of x square minus 2 minus 100, say it will be 2x minus 0, which is also 2x. So there are many functions whose derivative is 2x. We can see here. But when we reverse the operation, that means we find the integral, we only know about 2x. There could have been a constant of any value. It can be plus 4, it can be minus 100. So to sum this up, to wrap up the idea, we just end it by writing plus c with any integral. So let's start. If we want to find the integral of a function, we will have to learn some rules. So along with telling you about these rules, one by one, we will practice some examples for better understanding and clarity. Let's start. First rule is power rule, which is suppose we want to calculate the integral of x raised to n dx, which I have already told you. It is x raised to n plus 1 upon n plus 1 plus c. Okay, let's take an example. Suppose we want to calculate the integral of a dx. A is a constant here. We can also write it as integral of a into x raised to 0 dx. We know that any number raised to 0 is equal to 1. So we can write a into x raised to 0 dx here. So according to this power rule, it will be integral will be a into x raised to 0 plus 1 upon 0 plus 1 plus c. So simply it will be ax plus c. Okay, so what is the integral of 5 dx? Following the same rule, it will be 5x plus c. What will be the integral of say minus 3 dx? It will be minus 3x plus c. Okay, what is the integral of say 100 dt? Okay, dt here. So it will be 100 t plus c. Because this function was in terms of t, so we have written here 100 t plus c. T is the variable here. So I think by now you must have got an idea, basic idea about integration. So let's take some more typical examples. What will be the integral of, so what will be the integral of x square dx? It will be following the power rule. We will write here x raised to 2 plus 1 upon 2 plus 1 plus c. So it will be x cube upon 3 plus c. What is the integral of 5x dx? 5 is a constant here. We can move 5 outside the integral. We can also write it like this: 5 integral of x dx. So it will be 5 into x 1 plus 1 raised to 1 plus 1 upon 1 plus 1 plus c. So it will be 5 x square upon 2 plus c, or we can also write it like this: 5 by 2 x square plus c. Similarly, what is the integral of 6x cube dx? It will be, first of all, we will move 6 outside the integral. It will be x3 dx. So let's start it. It will be 6 into x raised to 3 plus 1 upon 3 plus 1 plus c. So 6 into x raised to 4 upon 4 plus c, or 3 by 2 x raised to 4 plus c. So let's take another example. What will be the integral of say 1 by x dx? We know that x here is the denominator with power 1. We can also write it like x integral of x raised to -1 dx. Okay, so following power rule, if we use power rule here, we will get -1 x raised to -1 plus 1 upon -1 plus 1 plus c. So it will be x raised to 0 upon 0 plus c. But this is not a sensible solution here. Why? Because any number divided by 0 is not defined. Suppose we have a given quantity and we divide it among 0 people, then that is not a sensible solution because items are there but we don't have any people to share it with. So that doesn't make any sense. So there is a different rule that we follow here. To find the integral of 1 upon x dx, we use log of mod x plus c. This is the modulus function here. Two vertical bars. These are the symbols of modulus function, or we can also call it absolute function. Okay, how did we arrive at this conclusion? We all know we will use counter process here. We all know that derivative of log x is 1 by x. So using the counter process, we can say that integral of 1 by x will be log mod x or modulus function x. Why modulus function? Because log of a negative number is not defined. So we know that modulus function, what does it do? It makes a value positive. So we will always use log mod x plus c. Let's do some more examples to understand some more rules of integration. So what is the integral of e raised to x dx? So before finding the integral of e raised to x, let us recall what is e raised to x. E raised to x is a exponential function. Exponential function because it has variable as its exponent and constant as its base. This e is also called Euler number, which has a value which is around 2.718. So the integral of ex dx is e raised to x plus c. Actually, it is e raised to x upon 1 into log e plus c. So what is 1 here? 1 is the derivative of x, which is the exponent of x, and log e. We all know that value of log e is 1. So it will be e raised to x upon 1 plus c, or simply e raised to x plus c. E raised to x. Derivative of e raised to x is also e raised to x, and integral of e raised to x is also e raised to x plus c. So what is the integral of e raised to 2x dx? It will be e raised to 2x upon 2. 2 is the derivative of x, 2x, which is the exponent of e, into log e plus c. So it will be e raised to 2x upon 2 plus c. Let's do some more examples. What is the integral of a raised to x dx? So it will be, we know that integral of exponential function e raised to x is itself, but in general the integral of a raised to x is not itself. We know that we will use counter process here. We know that derivative of a raised to x is a raised to x log a. Derivative of a raised to x is a raised to x log a. So dividing both sides by log a, what do we get? D upon dx. That means derivative of a raised to x upon log a is a raised to x. So we have proved that derivative of a raised to x upon log a is a raised to x, and we know that integral is the reverse operation. So we can say that integral of a raised to x is a raised to x upon log a. So what will be the integral of 5 raised to x dx? Okay, sorry, let's practice one more example. What will be the derivative of a raised to 5x dx? Okay, it will be a raised to 5x upon 5 log a. Okay, 5 is the derivative of 5x, which is the exponent of a. So it will be this a raised to 5x upon 5 log a plus c. Let's do one more example. What is the derivative of square root x dx? We know that square root x, we can also write it like this, x raised to 1 by 2 dx. So simply following the power rule here. Power rule, what was the power rule? It was x raised to n. Integral of x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. So following the same rule, we can write it x raised to 1 by 2 plus 1 upon 1 by 2 plus 1 plus c. So it will be x raised to 3 by 2 upon 3 by 2 plus c. Taking 2 to the upper side of the fraction, we can write it 2x raised to 3 by 2 upon 3 plus c. So let's practice last example we'll do here. What is the integral of 8x plus 4x cube minus 6x square dx? So we will work out the integral of each function separately. We'll write it like this. Integral of 8x dx, integral of 4x cube dx minus integral of 6x square dx. We can move constants 8, 4 and 6 to the outside of the integral. So we will write it like this. 8 integral of x dx plus 4 integral of x cube dx minus 6 integral of x square dx. So continuing, we can 8 into x 1 1 plus 1, okay, plus 4 into x raised to 3 plus 1 upon 3 plus 1 minus 6 into x raised to 2 plus 1 upon 2 plus 1 plus c. So it will be 8 x 2 plus 4 x raised to 4 upon 4 minus 6 x raised to 3 upon 3 plus c. So let's simplify it further. 2 and 8. 8 will be divided by 2, so we'll get 4. So it will be 4x square plus 4 and 4 get cancelled. X 4 minus 2x cube plus c. That's it. In this video, we learnt about the basic rules of integration along with examples. I hope you liked this video. In next video, we will do some more examples of integration to understand this concept more clearly. Thank you.